What does your smartphone have in common with a Stone Age tool? The answer might surprise you. Both represent the cutting edge of human innovation for their time. Both changed how humans interact with their world, and both showcase our species' remarkable ability to manipulate materials at a microscopic level. Our ancient ancestors weren't just simple tool makers. They were sophisticated engineers and scientists who developed technologies so complex that they continue to baffle modern researchers. While we pride ourselves on our current technological achievements, there are still ancient techniques and materials that we cannot fully replicate today, despite our advanced modern tools and understanding. Consider this. When a Stone Age craftsperson worked with obsidian, they could create blades with an edge just 3 nanometers thick. That's sharper than our most advanced surgical scalpels. These weren't lucky accidents or random discoveries. They were the result of sophisticated understanding of material properties and precise manufacturing techniques that took generations to perfect. The smartphones we carry today are built on thousands of years of cumulative human knowledge, but so were the intricate tools of our ancestors. Each Stone Age innovation was just as revolutionary for its time as our digital devices are today. These ancient craftspeople understood principles of physics, chemistry, and engineering that some of us are only now beginning to rediscover. What if I told you that some of these prehistoric technologies were so advanced that modern scientists are still struggling to understand how they were achieved? From self-healing Roman concrete to Damascus steel with carbon nanotubes, our ancestors developed materials and techniques that we still cannot perfectly replicate with all our modern technology and scientific knowledge. As we embark on this fascinating journey through prehistory, you'll discover that the line between primitive and advanced technology isn't as clear as you might think. Our ancestors were capable of extraordinary technological achievements that continue to challenge our assumptions about human innovation and progress. Before we dive deeper into these remarkable discoveries, don't forget to like this video and subscribe to the Dawn of Humankind channel for more incredible stories that will change how you view our ancient past. Together, we'll uncover the forgotten genius of our prehistoric ancestors and the amazing technologies they left behind. Traditional history books have painted a deceptively simple picture of human technological evolution. A neat, linear progression from simple stone tools to bronze, then iron, and eventually to our modern digital age. This orderly timeline, while convenient for textbooks, doesn't tell the whole story. The real narrative of human technological development is far more complex and fascinating. Archaeological discoveries over the past few decades have completely transformed our understanding of ancient human capabilities. We're finding evidence of remarkably sophisticated technologies in periods we once dismissed as primitive. These findings suggest that our ancestors weren't just surviving, they were innovating at levels that challenge our modern assumptions about prehistoric intelligence and capability. Take, for example, the sophisticated astronomical knowledge of prehistoric peoples. Long before the invention of writing, humans were constructing complex structures aligned with celestial events, demonstrating an advanced understanding of mathematics and astronomy. Sites like Göbekli Tepe in Turkey, built over 12,000 years ago, show evidence of architectural and engineering skills that weren't supposed to exist for thousands of years after its construction. The traditional narrative suggests that humans only developed advanced metallurgy during the Bronze Age, around 3300 BCE. However, recent discoveries have revealed evidence of complex metalworking techniques dating back much further. Some prehistoric communities had mastered techniques for treating metals that wouldn't be rediscovered until the Industrial Revolution. Perhaps most intriguing are the instances where ancient peoples developed technologies that we still cannot fully replicate today. The durability of Roman concrete, the flexibility of Damascus steel, and the precision of prehistoric obsidian tools all represent knowledge that was achieved, then lost, and in some cases remains beyond our current capabilities to reproduce exactly. These discoveries are forcing historians and archaeologists to rewrite their understanding of human technological development. Instead of a straight line of progress, we're now seeing a complex web of innovation, with peaks of advancement followed by periods of loss and rediscovery. Some ancient societies achieved technological breakthroughs that would not be matched for thousands of years. This new understanding challenges us to reconsider what we mean by primitive societies. It suggests that human innovation isn't a steady march forward, but rather a dynamic process of discovery, loss, and rediscovery. Our ancestors were far more sophisticated than we once believed, and their technological achievements continue to surprise and humble us. The implications of these findings extend beyond archaeology. They force us to question our assumptions about progress and human capability. They remind us that technological advancement isn't guaranteed to be permanent, and that valuable knowledge can be lost if not carefully preserved and transmitted to future generations. Picture yourself transported 40,000 years into the past. Along the banks of a pristine river sits a master craftsman, his weathered hands moving with remarkable precision. This isn't the crude toolmaker often depicted in popular media. This is a skilled artisan whose understanding of stone properties rivals that of modern material scientists. Watch as he carefully selects a piece of volcanic obsidian, reading its crystalline structure like a modern geologist. His techniques, passed down through generations and refined through decades of personal experience, allow him to strike the stone at exactly the right angle and with precisely calculated force. The resulting blade edge he creates is just 3 nanometers thick, a level of precision we can barely achieve with our most advanced modern technology. This ancient craftsman understands concepts we would now call physics and materials science, though he expresses this knowledge through skilled hands rather than mathematical equations. He knows exactly how the obsidian will fracture, how to control the pressure points, and how to create tools so sharp they can separate individual cells, a capability that wouldn't be matched until the development of modern surgical instruments. Now, shift your focus to another scene, thousands of years later. A female metalworker stands before her forge in ancient Damascus. She's a master of her craft, having learned the secrets of steel-making passed down through her family for generations. Her knowledge of metallurgy isn't written in books, but is encoded in carefully guarded recipes and techniques. Watch as she combines specific types of iron ore with precise amounts of carbon, heating and cooling the metal in a carefully choreographed process. She understands the importance of temperature control, timing, and material composition in ways that modern metallurgists are still trying to fully comprehend. The steel she creates contains carbon nanotubes, a microscopic structure that wouldn't be discovered by modern science until 1991. These weren't isolated geniuses. They were members of sophisticated communities that developed and maintained complex technological knowledge. The master flint knapper would have spent years as an apprentice learning to read the stones and perfect their techniques. The metal worker would have been part of a guild or family tradition that preserved and advanced their craft over generations. These ancient artisans developed their expertise through careful observation, experimentation, and the systematic passing down of knowledge. They might not have had our modern scientific terminology, but they understood their materials at a fundamental level. Their work required patience, precision, and an intimate understanding of natural properties that we're only now beginning to fully appreciate. Their legacy lives on in the artifacts they left behind, tools and materials that continue to astonish modern scientists with their sophistication. These weren't simple toolmakers. They were scientists, engineers, and artists who pushed the boundaries of what was possible with the materials available to them. When we examine their work today, we're not just looking at ancient artifacts, we're seeing the results of human ingenuity at its finest, proving that technological sophistication isn't unique to our modern era. These ancient craftspeople stand as testament to humanity's enduring capacity for innovation and excellence. Let's delve into some of the most remarkable lost technologies that continue to puzzle modern scientists. These innovations weren't just ahead of their time. In many cases, they achieved results we still struggle to replicate today. Roman concrete stands as perhaps the most impressive example of lost ancient technology. While modern concrete typically begins to deteriorate within decades, Roman structures built over 2,000 years ago still stand strong, especially in marine environments where our modern materials would have crumbled long ago. The secret lies in their unique mixture, which included volcanic ash called pozzolana, lime and seawater. But what makes this ancient concrete truly remarkable is its self-healing properties. When cracks form in Roman concrete, a remarkable chemical reaction begins. The structure actually repairs itself through a process involving calcium carbonate crystallization. This self-healing capability means that Roman concrete structures become stronger over time rather than weaker. Modern scientists have only recently begun to understand this process, but we still cannot perfectly replicate the original formula. Think about that. We can send rovers to Mars, but we can't match the durability of 2,000-year-old concrete. The Baghdad batteries represent another fascinating technological mystery. Discovered in Iraq, these simple-looking clay pots, dating back to the Parthian period, consisted of copper cylinders, iron rods, and an acidic solution. When assembled, these components could generate an electrical charge, more than 1,000 years before Alessandro Volta invented the first battery. While some scholars debate their exact purpose, evidence suggests these devices may have been used for electroplating, a sophisticated technique we typically associate with much more recent times. The ability to understand and harness electrical current this early in human history challenges our assumptions about ancient technological capabilities. Imagine ancient artisans using electrical current to plate metals with gold or silver, creating beautiful artifacts through a process we thought wasn't discovered until the modern era. Perhaps the most enigmatic of these lost technologies is Greek fire, a devastating naval weapon that brought terror to ancient seas. This mysterious substance, first used by the Byzantine Empire in the 7th century CE, had properties that seemed to defy the laws of physics. It would continue burning even on water's surface, could only be extinguished by specific substances, possibly vinegar or sand, and could be projected through tubes like a modern flamethrower. The formula for Greek fire was such a closely guarded secret that it was eventually lost to history. Modern scientists have proposed various possible compositions, including combinations of petroleum, quicklime, sulfur, and naphtha, but no one has successfully recreated its exact properties. The loss of this technology actually helped preserve the Byzantine Empire for centuries, as no other nation could replicate their powerful naval weapon. These examples demonstrate a crucial point about human technological development. Progress isn't always linear, and knowledge can be lost as easily as it's gained. Each of these technologies represents not just scientific achievement, but also a warning about how easily crucial knowledge can slip away if not properly preserved. Which of these ancient technologies surprises you the most? Consider the implications. If our ancestors could develop self-healing concrete, early batteries, and chemical weapons that defied natural laws, what other remarkable innovations might have been lost to time? Share your thoughts in the comments below, and don't forget to like this video and subscribe to the Dawn of Humankind channel for more fascinating explorations of ancient technologies. The existence of ancient technologies that surpass our modern capabilities presents us with a fascinating paradox. How do we explain that civilizations with far fewer resources and scientific instruments could achieve what we cannot. This question challenges our assumptions about technological progress and human development. The loss of these advanced technologies can be attributed to several interconnected factors that created a perfect storm of knowledge extinction. Let's explore the major challenges that led to these technological losses. Natural disasters and climate change played a devastating role in the loss of ancient knowledge. The eruption of Mount Vesuvius not only destroyed Pompeii, but also wiped out generations of accumulated knowledge in the region. The late Bronze Age collapse, possibly triggered by a series of earthquakes and climate changes, led to the disappearance of numerous advanced civilizations and their technological achievements. When entire communities were displaced or destroyed, their specialized knowledge often died with them. Wars and invasions perhaps dealt the most severe blows to ancient technological knowledge. The burning of the Library of Alexandria represents one of history's greatest losses of accumulated knowledge. The Mongol invasion of Baghdad in 1258 destroyed countless texts containing scientific and technological information. The sacking of Constantinople resulted in the loss of many Byzantine technological secrets, including the formula for Greek fire. In many cases, invading forces deliberately targeted centers of learning and technology to cripple their opponents' capabilities. Social collapse and migration have also played crucial roles in technological loss. As societies faced pressures from warfare, climate change, or economic collapse, specialized knowledge holders often scattered. Consider the master craftsmen who created Damascus steel. As their communities dispersed, the precise techniques for creating this remarkable material were lost. The knowledge wasn't written down but passed through generations of practical experience. Once that chain of transmission was broken, centuries of refinement and expertise vanished. The guild system, while excellent for preserving specialized knowledge, also contributed to its vulnerability. Many advanced techniques were closely guarded secrets, passed down only through careful apprenticeship within families or exclusive guilds. When these social structures were disrupted, the knowledge they protected often disappeared. The masters of Roman concrete kept their exact formulas secret, and when their social networks collapsed, so did access to their technological expertise. Religious and political changes sometimes led to the deliberate suppression of technological knowledge. New regimes or religious movements occasionally viewed certain technologies as threatening or contrary to their beliefs. Some knowledge was actively destroyed or allowed to fade away because it didn't align with new cultural or religious values. Language barriers and changes in writing systems created additional challenges. As languages evolved or died out, valuable technical knowledge became inaccessible. Ancient technical manuals, if they existed at all, became unreadable. Even when physical documents survived, the ability to understand them was often lost. The oral tradition of knowledge transfer, while effective for maintaining continuity within stable societies, made technological knowledge particularly vulnerable to disruption. Many advanced techniques were never written down, but passed from master to apprentice through hands-on demonstration. Once this chain was broken, the knowledge could be lost forever. The complexity of ancient technologies often required a supporting infrastructure of skills and materials. When one element of this complex system was lost, the entire technological process could become impossible to maintain. For instance, the creation of certain ancient metals required specific ores, precise furnace designs, and sophisticated knowledge of metallurgy. If any part of this system failed, the entire technology could be lost. These factors often worked in combination, creating multiple points of failure for knowledge preservation. A natural disaster might trigger population movements, leading to the breakdown of guild systems, while simultaneous political changes could result in the loss of written record. Understanding these challenges helps us appreciate both the fragility and resilience of human knowledge. It also serves as a warning about how easily crucial information can be lost, even in our modern digital age. Perhaps most importantly, it reminds us that technological progress isn't guaranteed. It must be actively preserved and protected. Each archaeological discovery reshapes our understanding of human progress and innovation. The common belief that technological advancement follows a straight line from primitive to advanced is being thoroughly debunked by evidence from our ancient past. These findings tell a more complex and fascinating story about human ingenuity and capability. Our ancestors didn't just develop solutions to their immediate problems. They created technologies that were so sophisticated we struggle to replicate them today. Consider the remarkable precision of prehistoric toolmaking, the durability of ancient building materials, or the complexity of early metallurgy. These achievements weren't lucky accidents, but the results of systematic observation, experimentation, and refinement over generations. The study of lost technologies serves multiple crucial purposes for our modern world. First, it humbles us by demonstrating that our ancestors were capable of extraordinary scientific and engineering feats without our modern tools and instruments. Second, it suggests that there might be alternative approaches to solving contemporary problems hidden in the technological achievements of the past. Modern researchers are increasingly turning to ancient technologies for inspiration in addressing current challenges. The self-healing properties of Roman concrete, for instance, are inspiring new approaches to sustainable construction materials. The sophisticated water management systems of ancient civilizations are providing insights for dealing with modern water scarcity issues. The ancient techniques of metalworking are offering new perspectives on materials science. Perhaps the most important lesson these lost technologies teach us is about the fragility of human knowledge. The fact that we've lost the ability to replicate these ancient achievements demonstrates that progress isn't guaranteed to be permanent. Knowledge can be lost as easily as it's gained, and technological advancement isn't a one-way journey. This understanding is particularly relevant in our digital age, where we must consider how to preserve our own technological knowledge for future generations. The rediscovery of these ancient technologies also challenges our assumptions about the capabilities of early humans. It suggests that innovation and sophisticated understanding of natural principles aren't unique to our modern era. Our ancestors were conducting complex experiments and developing advanced technologies long before the scientific method was formally defined. Looking at these lost technologies also reveals the cyclical nature of human innovation. Many of the problems we're trying to solve today, from sustainable building materials to efficient energy storage, had already been addressed by ancient civilizations in their own ways. By studying these lost technologies, we're not just learning about the past, we're potentially uncovering solutions that could be crucial for our future. These archaeological discoveries remind us that progress often involves rediscovering and reinterpreting knowledge from the past, rather than always inventing completely new solutions. They suggest that sometimes the best way forward might be to look backward, to learn from the accumulated wisdom and innovative solutions of our ancestors. The study of lost technologies isn't merely an academic exercise in historical curiosity. It's a vital source of inspiration and practical knowledge that could help us address modern challenges in sustainable and innovative ways. As we face unprecedented global challenges in the 21st century, the ingenious solutions developed by our ancestors might hold keys to building a better future. The precision achieved by our ancient ancestors continues to astonish modern scientists. Let's explore some of their most remarkable technological accomplishments that challenge our understanding of prehistoric capabilities. The obsidian tools crafted during the Upper Paleolithic period represent one of humanity's most impressive technological achievements. These stone implements were crafted with such precision that they could achieve a cutting edge just 3 nanometers thick, a level of sharpness that surpasses our most advanced modern surgical scalpels. To put this in perspective, these Stone Age tools were so sharp they could separate individual cells, a capability we typically associate with modern medical technology. When examined under an electron microscope, these prehistoric blades reveal an almost perfect edge, achieved through sophisticated knapping techniques that took generations to perfect. Modern attempts to replicate these tools often fall short of the original specimen's precision. The remarkable durability of Maya cement stands as another testament to ancient engineering prowess. This sophisticated building material has withstood 1,500 years of exposure to one of Earth's most challenging environments, the tropical rainforest. While modern concrete often shows significant degradation after just a few decades, Maya cement has endured centuries of hurricanes, torrential rains, and extreme temperature fluctuations while maintaining both its structural integrity and its original color. The secret lies in their unique mixture, which included local limestone, plant extracts, and specific mineral additives. Most remarkably, the vivid blues and reds used in Maya murals retained their vibrancy after 15 centuries, outlasting many modern synthetic paints exposed to similar conditions. Perhaps most intriguing is the discovery of carbon nanotubes in Damascus steel, a finding that has revolutionized our understanding of ancient metallurgy. These microscopic structures, officially discovered by modern science in 1991, were inadvertently created by ancient blacksmiths through their sophisticated forging techniques. The presence of carbon nanotubes helps explain the legendary properties of Damascus steel, its exceptional strength, flexibility, and ability to maintain an incredibly sharp edge. The steel's characteristic wavy pattern, known as damask, isn't just decorative. It's a visual manifestation of complex nanostructures that modern metallurgists are still working to fully understand. These ancient smiths achieved at a practical level what modern science is only now beginning to comprehend theoretically. These examples challenge our assumptions about technological progress. The ancient craftspeople who created these masterpieces didn't have access to electron microscopes, material science laboratories, or modern engineering knowledge. Yet, through careful observation, experimentation, and refined techniques passed down through generations, they achieved results that in some ways surpass our current capabilities. The implications of these discoveries are profound. If our ancestors could achieve such precision and sophistication with limited tools, what other capabilities might they have possessed that we haven't yet recognized? These findings suggest that human innovation and technical sophistication have deep roots in our prehistoric past, and that some ancient knowledge once lost still eludes our modern understanding. These weren't isolated achievements, but rather the products of sophisticated technological traditions that developed over thousands of years. They remind us that innovation isn't limited by the availability of modern tools or scientific theory, but rather by human ingenuity and careful observation of the natural world. Want to know more about any of these remarkable ancient technologies? Share your questions in the comments below, and don't forget to subscribe to our channel for more fascinating discoveries about humanity's technological heritage. The next time you unlock your smartphone, take a moment to reflect on the journey of human innovation that made this technology possible. While we marvel at our modern devices, the archaeological evidence reveals that our ancient ancestors were far from primitive. Their technological achievements, from precision stone tools sharper than modern surgical instruments to self-healing concrete that outperforms our best materials, challenge our assumptions about human progress. These lost technologies tell us something profound about human capability. Our ancestors weren't simply surviving, they were innovating, experimenting, and developing solutions that we struggle to replicate, even with our advanced modern tools. They understood principles of physics, chemistry, and engineering at a practical level that sometimes exceeded our theoretical knowledge today. The story of human innovation isn't a simple march forward from primitive to advanced. It's a complex tapestry of discovery, loss, and rediscovery. The technologies our ancestors developed and lost remind us that progress isn't guaranteed. Knowledge, once gained, can be lost if not carefully preserved and transmitted to future generations. Perhaps the most valuable lesson we can learn from these lost technologies is humility. Every archaeological discovery that reveals sophisticated ancient knowledge should remind us that innovation doesn't require modern laboratories or advanced computers. It requires human ingenuity, careful observation, and the systematic refinement of techniques over time. As we face the challenges of the 21st century, from climate change to sustainable development, the solutions developed by our ancestors might offer crucial insights. Their achievements remind us that sometimes the best way forward is to look backward, to learn from the accumulated wisdom of thousands of years of human innovation. The true measure of progress isn't just in creating new technologies, but in understanding and building upon the knowledge of those who came before us. Our modern smartphones might be marvels of miniaturization, but they stand on the shoulders of countless innovations developed, lost, and rediscovered throughout human history. Now, if these revelations about our ancestors' technological achievements have sparked your curiosity, you can help us continue uncovering these fascinating stories. Share this video with friends and family who might be interested in challenging their assumptions about ancient human capabilities. Every share helps spread awareness about the remarkable achievements of our prehistoric ancestors. Join us on this journey of discovery by subscribing to the Dawn of Humankind channel. By becoming part of our community, you'll get regular updates on the latest archaeological discoveries that are rewriting our understanding of human history. Click the notification bell to ensure you never miss our new releases about ancient technologies, lost knowledge, and the remarkable capabilities of our ancestors. Remember, every like, share, and comment helps us reach more people with these fascinating stories about our shared human heritage. Together, we can continue to uncover the forgotten genius of our ancient past and perhaps find solutions to our modern challenges in the wisdom of our ancestors. Don't forget to follow us on our social media platforms for exclusive content, behind-the-scenes looks at our research, and engaging discussions about ancient technologies. Join our growing community of history enthusiasts and help us piece together the remarkable story of human innovation. The mysteries of our past are waiting to be uncovered. Are you ready to join us on this extraordinary journey of discovery? Subscribe now and become part of this exciting exploration of humanity's technological heritage.